Hello everyone, welcome back. I wanted to talk about what makes an interesting emission and what happened in real life. And let me open up the 1 second. So in real life, what we have in explosions generally is we have some force, some kind of material that is compact, and then that there is force that gets applied to it that pushes that material and reacts with it. So we get spikes, for example, expanding in all different directions, emitting that powder and reacting with it. And what we need to do to get the for our explosion, we need to emulate this. We need to have a static dense material, and then we're going to apply force to it and expand it. And what we need to create is something similar to these spikes. So if we have, for example, half a sphere with density on it, and then we apply force that pushes that density in various directions along various axes, we can create a very interesting velocity variation that pushes this existing material into various directions with various velocity, and then we time all this happening with the expansion. So the next frame, the material is going to move, and then it's going to also expand, and the expansion is not going to be random. It's going to account for how the data moved, how the initial density moved. And with timing this with an expansion, we can create a very, very interesting source. The next part that we are going to do is, instead of just having one blast, one emission, we're going to have multiple blasts, multiple emissions timed differently. So we're going to have one, let it run for 3 frames, and have another one, and have another one after 4 frames. And this just to randomize what's happening to the source. And then we're going to let it run through our system. We're not going to change anything really. So let's go back here, and I'm going to create a sphere. Let's increase the frequency. I'm going to move it. Actually, let's leave it at the center. And I'm going to create a BDB from polygon. I'm going to convert this into a density, and let's call this out density sphere. Okay. Now, to create the sources, the velocity, we're not going to use this because this system is meant for tendrils, for something that has a curved path. We want something that is straight. So what I'm going to do is I'm going to create a grid, and I'm going to scatter some points, and I'm going to turn off randomization, relaxation. I'm going to have 150 points. I'm going to create a point, pop network, and then I want to shoot these points outward. So here, all points. I'm going to create the velocity here, just in the source directly. So I'm going to set this to 125, 120, 125, and then I want them to go upward. And let me change one thing. The birth, I'm going to set it to none. I don't want to jitter the birth time. I want them all to emit at 1 frame, and then if we hit play, we get this. And we're going to change the life expectancy to 1.5 so they don't live for too long. And if we hit play, we get that. We get continuous emission of points moving in this direction. And I'm not going to emit for too long. I'm going to emit only for 3 frames. So $f less than 3, and then that will give us a blast, and that's pretty much what I'm looking for. Now these guys are only moving in this direction, and I want something that covers the wider area. So what I'm going to do is I'm going to copy this and merge them, and I'm going to change the source here so that it doesn't go up that high and it goes up towards the left and right more. So I'm going to set the upward motion to 40 and here the variation to 15. And let's take a look at this guy by itself. Okay, now we have something that expands. See that? I'm going to connect both of them. Cool. So we have something that goes up, and then these guys go in this direction. And we can sculpt this later, it's not a problem. So let's import those points. And geometry. Okay. And let's try, we have the ID attribute, let's try and create trails from these. So preserve geometry, let's increase this count, let's lower it. And let's hit play and see what we get. It's not working. Well, why is that? Well, the reason for that is because it's not using ID or anything, it's using the point number, and the point count is changing every frame, so this method is not going to work. Well, we're going to create our own method. So let's create the point Bob, and we have the velocity. We know what the velocity is of these points. So if we take these points and let's say we add the velocity to them. Okay, and let's multiply the velocity by 0.10. Sorry, 0.1. I want it to be lower. So this is the original, and this is with a 10% of the velocity pushing the points, offsetting them or displacing them. It's pushing them in this angle. I don't want that. I want to push them backward. So now 10% of the velocity is being applied to the points. It's too much, so I'm going to lower this to 0.01. So see, we're slightly shifting them. Okay, I'm going to expose that. So I'm going to create a multiply, and I'm going to expose this and set it to 0.01, minus 0.01. Actually, let's set it to 0.01 and then add the negative here. So multiply by a constant, negative, okay. And we've, that's one, taking those points, you can see already. And I'm going to lower this 0.05 even lower, 0.2. Okay, let's copy this, make another one, and set it to 4. Let's make another one, set it to 6. Let's make another one, set it to 8. And all of you are probably thinking why I don't do a for each loop, and that's what I'm going to do. So I'm going to merge all these, and you can see now we're trailing those points. And this will not change, it will not change based on the it will work with the point count changing independently. As long as there is a velocity vector, this will work. So I'm going to use Vex for this actually. So I'm going to create a wrangle node, and I'm going to paste some Vex code that I have. And what it's going to do is I'm going to loop 20 times. And then each time I'm going to take that I, which goes from 0 to 20, and then multiply it by a step, which I will set to 0.1 for now, or 0.0002. And there we go. Now I can run this. In the previous example we did it 6 times. I can say, okay, I want to run 6 times, and that will give me 6 copies. I can run 40 times and lower the step, so we have more points, and this is what we're going to use now. So if I hit play, you can see we're getting something, the interesting tendrils. But the difference is these are straight, and that's going to generate a different velocity vector that is going to be more interesting. So the next part is I'm going to delete everything that is below 0. Okay, so cool. And then I'm going to take these points and replicate them as always. So I'm going to create a point replicate, and let's set it to sphere. Set the number to 10. Scale to 0.5. And let's add some noise. Cool. And I'm gonna jitter the points a bit. Yeah, something like that. I don't want it to be too uniform. Cool, and then what I'm going to do is I'm going to create a random vector on these guys. So I'm going to create a, let's call it n so we can view it. And I'm going to set it to normal Gaussian. And this should give me random vectors. And we'll see what we're going to do with these guys later. Now, what I'm going to do is I'm going to multiply the velocity with this. I'm not going to multiply. I'm going to use these normals as my velocity. So I'm going to copy n into v. So I'm going to set v directly here. Sorry about that. And then fluid source, this guy, same like we did before. Actually, let's copy this. You can go, we can create the same idea that we did for these sources by creating a proper vector. In this case, I'm just gonna create something randomized, and let me lower the resolution here. Let's try one. Points because it's too low. Let's increase this. Okay, getting something. Let's increase it. Actually, I'm gonna increase this higher because this is going to be used as a pump force, and the radius is not going to really matter. Actually, I think we have to have something thick for the sim to capture the details from, and this is going to be used for injecting velocity. Now, the other thing that we need to change here is instead of source smoke, we need to change this to pump. Cool. So let's call this null. Out spikes rand pump for random vector, randomized velocity, and then the other one, we're going to take these points as they are, and we're going to create a pump force from them using the velocity vector. I want both. I want velocity that pushes outward, and I want velocity that is randomized but only placed in these areas. So actually, yeah, let's create that. Let's copy this guy. Let's see what we have. Okay, cool. Stem points. Sorry, I didn't copy the source correctly. Okay, let's see now. Cool. And let me increase the density. I think the resolution is too high and it's going to be hard to work with them. So let's increase this. Okay, cool. And we have the velocity and everything set up. Perfect. And the other thing I want to change is we talked about having random emissions, random emission or timed emission. And I'm going to use a time offset. I'm going to shift this 4 frames. And I'm not going to use this copy. I'm not going to use the same velocity, so I'm going to create a wrangle node. I'm going to reduce the amount of velocity I get from this. So I'm going to multiply it by 0.3, only 30%. And then I'm going to add another one that happens later after 7 frames. And it's going to be 20% only. I'm going to merge all of them. And now we have 1, 2, and 3. See, the last 2 are timed one after the other. And I don't have the delete node, so let me add a delete. My expression polar ty is less than 0. We want to delete the points. Cool. And now, where is that? Oh, I see. Sorry. It needs to happen after the wrangle. Makes sense. Okay. Okay. I'm going to cache these 2 guys. I'm going to copy this. Pump spikes. And I'm going to cache only 20 frames tops. And then this guy is going to be spikes rend. And we copy this. Okay, cool. So we have these 2 sources. We have a new density, and I'm going to cache them, and we'll continue in the next video. Thank you guys for watching, and see you in a bit.